Hi, I'm Mrs. Kessers from Washington High School, and this section is on radicals. Alright, so first what I want you to do is write each radical in the simplest radical form. So what you always are looking for is perfect squares within those radicals. So let's go ahead and look at this. We've got 28. Okay, so radical 28. So what I want you to do is think about all the different factors of 28, and you want to think of the one that has a perfect square. So a perfect square in 28 is 4. So you have radical 4, radical 7. So this breaks off. Now, your 4 is your perfect square. So square that off and you get 2. So 7, there's no other perfect squares in that, so your final answer is 2 radical 7. That's it. Now let's look at 56. Okay, so we've got 56. So when you think about that, the first number that might come to mind is maybe 8. Okay, so 8 is not a perfect square, but what I want you to do is that's the one that you think of. Okay, so we've got radical 8, radical 7. Okay, so when you look at radical 8, what is a perfect square in 8? Perfect square in 8 is 4. So you have radical 4, radical 2. Square off your 4 and you get 2. So what you want to do then is you have 2 and then you have these two radicals. Radical 2 times radical 7 gives me radical 14. So my final answer is 2 radical 14. Alright, now let's look at the cubed root of 80. Okay, so now when you have that's what that little 3 out there is. You don't want to think of perfect squares. Instead, we want to think of perfect cubes. So a perfect cube is 8 because 2 cubed is going to give me 8. So you want to split this up into the cubed root of 8 times the cubed root of 10. So that cubed root of 8 is right here, which is going to be 2 cubed root of 10 will be your final answer. And you have to have that little 3 as that index because that makes you know that it is a cubed root. Alright, so now that we're good with simplifying, okay, we're going to do a little bit more with just adding and subtracting. So what I want you to think of, when you have radical 2 and radical 2, okay, you can actually think of those as both being x's. Okay, because this is like an x and this is an x. They have the same radical, so that means that we can put them together. So 3 radical 2 minus 5 radical 2 is going to give me 3 minus 5 gives me negative 2 radical 2. Let's say you had 3 radical 3 minus 5 radical 2. You could not put these together because radical 3 and radical 2 cannot go together. So that would be your final answer. All right, let's go ahead and look at this next one. We have 3 radical 15 times 9 radical 3. So you multiply the things on the outsides and then everything on the inside. So 3 times 9 is going to give me 27. Then radical 15 times radical 3, multiply those two numbers and you get radical 45. Now you have to look at radical 45, okay? And let's look at that and say, is there a perfect square in it? And when you think about 45, actually there is a perfect square. It's going to be radical 9 and radical 5. Square off 9 and you get 3. So now we have to do 27 times 3, which is going to give me 51 radical 5, which is going to be my final answer. Make sure you multiply these two. You cannot forget about that 27. So my final answer is 51 radical 5. All right, let's look at some more. So simplify, okay? Looking underneath all these radicals, you know that you cannot put those together first because they don't have the same radicand, which is that number underneath that radical. So instead, look and see, can you break these down anymore? See if there's perfect squares in them. So with 12, there's a perfect square of 4. So you have radical 4, radical 3. Square off your 4, you get 2. 3 times 2 gives me 6 radical 3. Now let's look at 27. There's a perfect square in 27, which is 9. Radical 9, radical 3. Square off 9 and you get 3. Again, you have to remember about this 2 up here. 2 times 3 gives me 6 radical 3. Then radical 3, you don't have a perfect square, so just drop this whole thing down, minus 4 radical 3. So let's add them together. 6 plus 6 gives me 12, minus 4 gives me 8. So you have 8, and then just think of a radical 3 like an x and just tap it on the back. 8 radical 3 is my final answer. All right, let's keep on doing some more stuff with radicals. So again, we want to multiply. Okay, we did a little bit of this in the beginning. Let's do some more. Take that 4 and distribute it to both. Okay, you want to multiply your constants by each other and the stuff, your radicals, that stuff underneath the radicals by each other. So think of a 1 out here. 4 times 1 just gives me 4. Radical 3 times radical 6 gives me radical 18. Then 4 times 3 gives me 12. Radical 3 times radical 12 gives me radical 6. Now again, you have to check to make sure that you have it completely simplified. Is there a perfect square in 18? Yes, 9. So you have radical 9, radical 2. Square off 9, you get 3. So really, we have 4 times 3, which is going to give me 12 radical 2, plus, if you look at this, radical 6. You do not have a perfect square in radical 6, so it stays the same. So you get 12 radical 6, which is your final answer. 12 radical 2 plus 12 radical 6 is your final answer because these are not the same, so you cannot add them together like terms. All right, let's go ahead and multiply this one. Now we're going to be foiling, okay? So when you take this, multiply here. 2 radical 3 times radical 3. You can put a 1 in front of here. 2 times 1 gives me 2. Radical 3 times radical 3 gives me radical 9. And just leave it for right now. Then we have 2 radical 3 times 2 radical 2. 2 times 2 gives me 4. Radical 3 times radical 2 gives me radical 6. Then just radical 2 times radical 3 gives me plus radical 6. Radical 2 times 2 radical 2 will give me plus 2. Then 2 times 2 gives me radical 4. Now let's go through and square off anything that are perfect squares. My 9 is a perfect square. Square it off and you get 3. My 4 is a perfect square. Square it off and you get 2. Okay? So you have to multiply these. All right? 2 times 3 gives me 6. Then let's look at our radical 6's. Those cannot be factored anymore, or simplified anymore, but you can put them together because they both have the same radical. So 4 radical 6 plus radical 6 gives me 5 radical 6. Then 2 times 2 gives me 4. Put this all together. 6 plus 4 gives me 10 plus 5 radical 6, which is my final answer. And it's kind of crazy because you have something so crazy like this and it breaks down really, really easily. All right, let's go ahead and look at some more examples. Let's say we have fractions, okay? Now, when you're simplifying fractions, you can never, ever, 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 ever have a radical in the denominator, okay? So when you have radical 18 over radical 4, what you want to do is break up that radical. Make it radical 18 over radical 4. Now, if you look at this, it's really easy because we have a radical 4 on the bottom. It was nice that you have a perfect square, so square that off and you get 2 on the bottom. Now, but let's look at 18. Is there a perfect square? Yeah, there's 9. So break it off into radical 9, radical 2, square off your 9, and you get 3. So then we have 3 radical 2 on the top. We got our radical out of the bottom, which is the number one main concern, and then you simplify your top. So we are all done. You cannot cancel these 2's right here because one's underneath a radical and one is not. So you cannot cancel those 2's. All right, let's go ahead and look at radical 2 over radical 3. Now again, you want to split that up and put a radical on top, radical on the bottom. Okay, now we do not have a perfect square on the bottom, so we can't really work with that by just squaring it off. So instead, what you want to do is multiply it by radical 3 over radical 3. And the reason why I do that, because radical 3 times radical 3 is radical 9, which is a perfect square. Okay, so look at the top. Radical 2 times radical 3 is radical 6. Square off the bottom and you get radical 6 over 3. So you are able to get rid of your radical by when you multiply by that whole entire radical on the bottom. All right, let's try one more example like this. Now we have radical 8 all over 2 times radical 24. Now I really don't feel like multiplying 24 times 24 and 24 times 8. But what do you notice with both of these radicals right here? Okay, you recognize that you can go through and cancel those. Because they are both underneath radicals, you are able to cancel them. So that means you have 2 on the bottom. Now, 8 over 24 is going to leave me with a 1 on top, and you can keep that radical. Radical 1 is just 1. And then if you have 8 over 24, that means that we are going to have radical 3 left in the bottom. Now we're still not done yet because we still have a radical in the bottom. So that means that we need to multiply by just that radical. This 2 does not have a radical. So just multiply by the radical 3. Radical 3 over radical 3. So we get radical 3 on the top. Then on the bottom you have 2 times radical 9. Square off 9 and you get 3. So we have radical 3 all over 2 times 3, which gives me 6. You cannot cancel these numbers because one has a radical and one does not. So my final answer is radical 3 over 6. Okay, now we've still got a little bit more with fractions. Now we're going to be rationalizing denominators. Now this is the last topic when you have fractions with radicals. Alright? Now instead, you cannot just multiply by radical 3 because you're going to still have a radical in the bottom. Instead, you have to multiply by something special called a conjugate. Now, the conjugate of this bottom right here, okay, is going to be radical 3 minus 2. So you always just change the sign in the middle. Don't change anything else. Change the sign in the middle. Then on the top, you have radical 3 minus 2. You multiply by the conjugate. All right, so let's go ahead and start multiplying. We do 4 times radical 3, which gives me 4 radical 3. 4 times 2, which is going to give me minus 8. Then on the bottom, radical 3 times radical 3. Now I just want you to write it right underneath here, okay? So radical 3 times radical 3 gives me radical 9. Radical 3 times 2 gives me minus 2 radical 3. Now positive 2 times radical 3 gives me plus 2 radical 3. Then positive 2 times negative 2 gives me negative 4. Now, do you notice that these two guys completely cancel each other out? Your radical 9 squares off into 3. So 3 minus 4 gives me negative 1. Okay? Notice how these two radicals canceled out. If you did something wrong, or if they don't cancel out, then that means you did something wrong. So they always, always, always cancel out. So what you have here really, okay, is 4 radical 3 minus 8 all over negative 1. When you have a negative in the bottom, you got to move them up, change all the signs. So that means my final answer is negative 4 radical 3 plus 8. That is going to be my final answer if it was completely simplified after rationalizing your denominator.